This is lesson 11.1, probability. The objectives for this lesson are, I can identify a sample space and find sets. I can find the probability of a single event or compound probability. So let's first talk about types of sets. So a set is, anything that we're looking at. So like we call it a sample set in probability. So a sample set would be like those trees that we made in the last unit of possible coin flips or possible rolls of a dice, right? So sometimes we work with more than one set together. And then we have two possibilities. We have an OR set, which is called a union, and we use a little U symbol to say that. So like if you had two sets A and B, you do A union B or A or B to signify the union of the two sets. There's also called intersection, which is like an upside down U. That's sometimes called AND. So we have or AND. So A and B, that's elements in both A and B. So this is like, let's say you were going to make an outfit, right? So you had a set of 5 different shirts to choose from and a set of 6 different pants to choose from, right? Then you could do things like A or B, A and B. Okay, and then finally we have the complement or not set. So this is elements that are not in a certain set, right? So like if you wanted to exclude something, like you say, I want to choose this but not this, right? Okay, so when we are having a set, there's 3 ways we can arrange our information about sets. Okay, so I'm going to just show you with dice roll, okay, an example. So you can make, like you're going to roll a dice, you can make a sample set that's a chart. So let's say we go like this. When you first roll a dice, you could get either 1, 2, 3, 4, 5, or 6. So like that's the first die, right? The first dice. And then the second one, if you rolled a 1, it could be a 1, 2, 3, 4, 5, or 6. If you rolled a 2, it could be a 1, 2, 3, 4, 5, or 6, and so on, right? So this is a chart that shows us all the possibilities for rolling 2 dice. This is our sample set, right? So you can make a chart like this. Charts are really useful. I like charts a lot. They don't take as much space as a tree diagram for some things. So like for example, this would be the dice roll 1, 1. And here you have the dice roll 2, 4, right? Etc. Okay? And of course you do have the tree, the good old tree that you learned last unit. So like if you flip a coin, you could get heads or tails. On the second flip, you could get heads or tails. Right? Third flip, you could get heads or tails. The only problem is tree diagrams start to get difficult, right? Especially if you're doing more than heads or tails, you run out of room. So I really like the charts a lot. The third way is a Venn diagram, if you've seen those before. So Venn diagrams show what sets have in common, right? So let's say you were like drawing candies out of bags, like 2 different bags, and one bag has blue, red, green, and yellow, and the other bag also has green and yellow, and then it has pink and orange kind of thing. So you can see what things are in each set and also what things they have in common when you use a Venn diagram. That's useful. Okay, so let's practice working with a chart. So our first example, some students were asked what pets they have at home. The following table shows the results. Okay, so you see the number student, like student number 1, doesn't have any pets at all. Student number 2 has a dog and a cat, right? Student number 4 has just a dog. Okay, so you can see how to read this chart. It's not too bad. All right, and then we've been given over here a key, right? D stands for student has a dog. This makes it easier to write the set and to talk about the set, to have these abbreviations, right? Talking about what it is. All right, so in our first example, we want to list the elements of C. So remember that C stands for student has a cat. So we're going to list the elements of C. So if we go here to cat, student 2, 7, 9, and 10 has a cat. So we would write 2, 7, 9, and 10, right? It's not too bad. Okay, so next we're given D and B. D and B, okay? So this is going to be students that have both a dog and a bird. So they have to have both. And means both, right? So I remember, if you have trouble remembering which is or and which is and, I remember that the little upside down U kind of looks like in the N in and. So that one is and then the other one is or, right? So remembering the difference between which is and which is or, that can be important. All right, so we're looking for dog and bird. So as we come over here, so this student has a dog but no bird, so they're not one, right? We have to look for both dog and bird. So who has both a dog and a bird? Student number 7, and that's all. So just 7, okay? All right, next part, we're looking for H or F. So H or F, this means they could have a hamster or a fish. So it could be just a hamster, just a fish, or both. Or means, right, everything in both. So let's see, hamster, number 5 has a hamster, and number 5 and number 6 has a fish. So 5 and 6. This is one where you could use the little Venn diagram, right? So who has a hamster? Number 5 has a hamster. And who has a fish? Number 5 and number 6. So everything in the Venn diagram goes for or, okay? So it's kind of like if you think about and versus or with a Venn diagram. So an or, let's get a highlighter here, an or is going to be everything, right? That's the or. An and is going to be only what's in the middle, okay? All right, let's do the next one. So this time we're asked to list not B. Remember the little line over the top means not B, okay? So this is everything except B. So it's every student except bird. So what it's helpful to do is to go to B, so B is bird, and I'll circle both birds. And then we write everything that was not bird. So bird was student 7 and student 9. So it's everything but 7 and 9. Okay. So there we go. Everything except 7 or 9, not B. Next one we have not dog and cat. So if we went to dog and cat, who has both a dog and a cat? Remember, and means both. So number 2 has both a dog and a cat. 7 has both a dog and a cat. 10 has both a dog and a cat. And then we want not. Okay, so student 2, student 7, and student 10 had a dog and a cat. So we're going to do everything but those 3. So 1, 3, 4, 5, 6, 8, and 9. Okay, not dog and cat. All right, finally, we're going to do not dog or cat. So this time it's either a dog or a cat. So it's everyone with a dog, everyone with a cat, and they're all excluded because we're doing not. So not 10, not 9, not 7, not 4, not 2. Okay? So what's left? 1, 3, 5, 6, and 8. Okay, so hopefully that makes sense. Now let's go on to the next example. So list the elements of the following using A contains 4, 5, 6, and 7, B contains 4, 6, 8, and 10. Okay, so A or B. So A or B, remember that in a Venn diagram, A or, the or is everything. So it's everything that's in A or B. So you only have to list things that they have in common once. Like they both have a 4, I'm only going to put 1 4 in my set list, okay? And then A has 5, they both have 6. A has 7, B has 8, B has 10. Okay, so it's everything, but we only list repeats once. All right, let's try A and B. So now we're listing things that are in both A and B. They have to be in both, so things they have in common, right? So they both have a 4, they both have a 6. So 4, 6. All right? Okay, so now that we've established how to count items in sets, we're going to talk about what probability is. So probability is when we measure how likely an event is to occur, right? So the way we write this is we write P of the event with parentheses. So like, let's say we were rolling a dice and we wanted to know what's the probability of rolling a 5. Whoops. Okay, so what's the probability of rolling a 5? Probability is always written as a fraction. And the way you do it is you count the number of ways to succeed. In other ways, the number of possible ways to get the 5 out of the number of possible outcomes. So if you're just rolling a single dice, there's only one 5 on that dice, so there's only one way to get a 5. And then how many possible outcomes on there? A dice has 6 different faces, so there's 6 possible outcomes. So the probability of rolling a 5 is 1/6. Okay, so we always write them as fractions. So let's try this example. A pair of dice are rolled. What is the probability that the sum will be even? Okay, so on these, it's really helpful to draw yourself the sample space. Remember the chart that we did? So if you make a little sample space for 2 dice, I would recommend drawing a sample space for 2 dice because we do a lot of questions with 2 dice. Write one in pen, and then you can like circle things and mark things on it with a pencil and then erase it for the next problem just so you have a nice dice sample space to work with, because there's a lot of questions with this. So if you just have a nice little sample space like this written out, it helps a lot, okay? All right, so I'm going to make a sample space, and I highly recommend that you make one somewhere on a scratch paper or something in pen, so you can mark on it with pencil and then erase to use it again. Okay, so a pair of dice are rolled. What's the probability that the sum will be even? All right, so let's see. 1 plus 1 is even, so I'll circle that one. 1 plus 2 is odd. 1 plus 3 is even, right? So see what I'm doing? I'm counting up how often this occurs, right? The probability that the sum will be even. The first step is we have to count up the number of ways we get even. So we have to count up the number of even sums, and we have to put it out of the total. So how many total choices do you have here if you roll a dice? So we have 6 times 6, right? So you have 6 times 6, we have 36. So when you're doing a pair of dice problem, it's always going to be out of 36. Okay? So we got to count up. So it happens that anytime you do an odd number plus an odd number, you get an even number. Okay? And if you do an even number plus an even number, you also get an even number. Even plus odd is when you get odd. So we'll do all of the odd rolls and all of the even rolls. Okay? So right, 4-2 is even. 4-4 is even, right? 5-1 is odd. 5-3 is odd, etc. Okay? So how many have we circled here? We've circled 18. So the probability of an even is 18 out of 36. We always reduce our fractions, or 1/2. Okay? Next example, there are 6 students presenting projects in a history class. The teacher is randomly determining the order in which the students will present. Each student only presents once. Brooke is one of the 6 students. What is the probability that Brooke will present first? So this one's actually easier than it sounds. So in our last one, it's kind of like this. You'd have 6 students, right? And we counted how many choices do you have for the first student, because we're looking for present first. You have 6 choices for the first student. But this time we're doing probability, right? So this is our total. So probability of Brooke being first, so we'll put a B1, Brooke first, right, is out of 6. There's only one Brooke, so 1 student out of 6 for the first choice. Okay, so it's pretty easy actually. Okay, next one. using permutations and combinations to find successes or number of possibilities. So sometimes when we're doing probability, then the problems get complicated. We have to use the permutations and combinations that we learned in the last unit in order to be able to count our set, our successes. Okay, so you remember permutations and combinations. You have to know if the order matters or doesn't matter. Remember, a permutation, the order matters, and a combination, the order doesn't matter. Okay, now this is important because when we do the permutations, we use the counting principle. Remember, just like what we were just doing, like you put a space for each one and say there's 5 possibilities for the first thing and 4 possibilities and so on. You remember that. That was the counting principle for permutations. And combinations use that NCR on your calculator, right? Like 5, choose 3, right? So you'd type in NCR 5, 3, right? So you got to remember this from the last unit. Okay, let me just erase this really quick. And there is a little clue. This is a helpful clue that you can remember. When events happen simultaneously, it's usually a combination. And when events happen one at a time, it is usually a permutation. So, for example, if you have shirts in a closet and you're going to pick 2 to wear, right, or something like that. If you grab both at once, we're going to calculate the possibilities using combination. If you're going to grab one and then another, we're going to calculate the things using a permutation. Okay, so simultaneously combination, one at a time permutation. All right, so let's try this. Example 5, a bag of candy contains 12 red, 11 yellow, 5 green, 6 orange, 5 blue, and 16 brown candies. 2 candies are randomly selected from the bag. What's the probability that they will both be orange? All right, so if we're grabbing out 2 candies from the bag, we're grabbing them at the same time. So this is going to be a combination. Okay, and we want the probability that they'll both be orange. So remember, to calculate a probability, you want the number of total weigh, right? So number of orange out of the total. Okay, so combination. So this is how this works. Okay, so there are 6 orange in the bag. Since this is a combination, we're going to calculate this with 6 choose 2 because we're selecting 2 candies. So out of 6 orange, we're choosing 2, right? Now, how many total are there? So if I add up 12 red plus 11 yellow plus 5 green, right? So I'm adding it up on my calculator to get the total. So there are 55 total candies in the bag. And again, we are choosing 2, right? So we're saying if you have 6 orange and you're choosing 2, 55 total, choose 2, okay? So you can type it in your calculator just like this. So I'm going to try that now. I go into the functions and get my NCR, type 6, 2, divided by, go back into functions, NCR, 55, 2. Okay, I get a decimal and I'm going to push that little fraction button, right? Because probabilities are written as fractions. There's actually 2 ways. Probabilities are written as fractions or as percents. So the decimal for this was 0.01 repeating. So if you move this over, it's also 1%, right? Close enough. Okay, so you'll see in the world, I guess, in the real world, probabilities expressed either as fractions or as percents, okay? All right, so next one, same situation. This time we're going to do 2 candies selected from the bag. What's the probability that a yellow candy is selected and then a brown candy? So this and then is a key. So and then, we're not selecting in order this time, okay? This one's a permutation now, okay? So permutation, we're going to do the probabilities one at a time with the counting principle and multiply them together. So first, probability that a yellow is selected. So for yellow, there are 11 yellows out of 55 total. And then after we've drawn one, we're trying to get a brown. There are 16 brown in the bag. And here's where kids will sometimes make a mistake. there are now only 54 candies to pick from because we picked one, right? We picked a candy here. So now there's only 54 left for the second draw. Okay? So let's see where everything came from. So we did 11 yellows out of 55 total and then 16 browns out of 54 total because we draw one. So now I'm just going to type that in my calculator. So 11 divided by 55 times 16 divided by 54. I get the decimal, push the button to get the fraction. 8 out of 135. Okay? And next one, 6 candies are randomly selected from the bag. What is the probability of selecting one of each color? So again, we're grabbing 6 and it doesn't say anything about, right, first grab this and then grab another, so it's happening all at once. Okay, so this is kind of crazy. All right, so one of each color. So there are 12 reds. So the way this works is we're going to take out of the 12 red, choose one. Out of the 11 yellow, choose one. Out of the 5 green, choose one. Whoops. Out of the 6 orange, choose one. Out of the 5 blue, choose one. And out of the 16 brown, choose one. That's one of each. See what I've done? So I've chosen one of each. Okay? And then remember that there were 55 total, and we're choosing one of each. We're choosing 1, 2, 3, 4, 5, 6. So 55, choose 6. Okay? So this is crazy to type in the calculator. It's a little bit of a pain to do. So you just have to type it all in. So put parentheses around when you do these. Put a starting parentheses around like this so that the whole entire bottom will all be divided by that 55, choose C. So I'm putting a starting parenthesis, and then I'm going to go into function and get my NCR, 12, 1, right? And you just have to type this all in. It takes a while, okay? Okay, so I've typed that all in my calculator. You get a decimal, push the fraction button, and I get 128 out of 11,713. All right. All right, so next up, let's talk about compound probabilities. So when more than one event is happening, it creates a compound probability. If we have a compound probability, then we use the multiplication rule. Okay, so there are two kinds of things that can happen. You've got independent events like flipping a coin. The first event happening doesn't change the probability that the second event happens. So when you flip a coin, every time you can get either heads or tails, right? It doesn't matter. If it's the first flip, if it's the 100th flip, you always can get either heads or tails, right? So when you flip a coin, if you got heads the first time, it doesn't change what you can get the second time. They're independent, right? So the way we calculate independence events, we say the probability of A and B is probability of A times the probability of B. You just multiply them together, okay? Dependent events are like drawing cards without replacement. That means you draw one and don't put it back again. So if the first event happening does change the probability that the second event will happen. So right, if you have a deck of cards and you draw out an ace, now you only have 3 aces left in your cards, right? So it does affect the outcome, the second one. All right, so this time we still multiply the probabilities, but you have to make sure that you modify the second probability to make sure that it accounts for what happened on the first draw, right? So our last question had ones like this, right? When we drew, we chose a candy and stuff, and then you only had a certain number left. You only had 54 left the second time, kind of thing. All right, so let's try this. For a standard 52 card deck, find the following probabilities. What's the probability that you will draw 3 diamonds? Okay, so this doesn't say draw a diamond and then draw another diamond and then draw another diamond. It says 3 diamonds. So it's happening all at once. That's a combination. Okay, unless it says draw this and then this and then this, you assume that it's happening all at once and it's a combination. Okay, so the probability of 3 diamonds. So how many diamonds are there in a deck anyway? So if you're not sure about decks of cards, okay, you know what it looks like, I have linked a sample deck of cards, a picture of one on the canvas so you can look at what a deck of cards looks like. So anyway, there are 4 suits or shapes, right? Hearts and diamonds and clubs. There are 4 of them. All right. So that means that in a 52 card deck, a quarter of them or 13 of them are diamonds. Okay? So since we're using combinations, right? Oops, sorry, hold on a minute. So since we're using combinations, there are 52 total in the card, right? And we're trying to draw 3. And there are only 13 diamonds. Draw 3. Okay, so hopefully that makes sense. There are 13 diamonds in the deck, and we're going to choose 3 out of 52 total cards in the deck. Choose 3. Okay, so I'm going to type this in. So I'm typing in NCR 13,3 divided by NCR 52,3, and then hit that fraction button. So I get 11 out of 850 for my probability. Okay, so now what is the probability that you will draw a jack, keep it, then draw a 10? So see how this time we're drawing something and then drawing something else, so it's one at a time. So this one is going to be permutation. Okay, so draw a jack. How many jacks are there in a deck? So each one, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen. There are 4 of each of those, right? So you have 4 jacks out of the 52. And then we're keeping the jack. We're not keeping it, putting it back in the deck. So there are also 4 10s in the deck, but we kept our jack. So now there's only 51 cards left to choose from, right? All right, so let's type this in. 4 out of 52 times 4 out of 51, and then push my fraction button to get a fraction. I get 4 out of 663 is the probability of that.